morning students, I am Ankit and today we will discuss first chapter solid state. In the class I have told you about all 16 chapters of chemistry and the content of each chapter we have discussed in the class. Okay, so first chapter is solid state and marks distribution is 4. Sometimes it varies from 4 to 5. Okay, so in these 4 marks you will get 100% one numerical and 2 question may be direct like conceptual question, MCQ format, fill in the blanks format. Okay, so first topic is crystalline solid and amorphous solid. Generally solid is classified into 2 categories. First is crystalline solid and second is amorphous solid. Okay, and about solid state, gaseous state and liquid states you have studied in the previous classes. So what is crystalline solid? Look for the first point of difference is regular internal arrangement of particle represent the crystalline solid. So what does it indicate? You know that every state is made up of particles. If the arrangement of these particles is tightly packed, then state is known as solid state. And if the pattern of this tightly packed particle is regular pattern, then it is known as crystalline solid. So what does indicate? Regular indicates the perfect or proper arrangement as you sit inside the class during any period. So this pattern of the packing is known as crystalline solid. And when you move outside the class during half time, that is irregular order. One student is here, second student is here, third is inside the basketball court. Okay, so this pattern is known as irregular arrangement, and irregular arrangement of particle represent the amorphous solid. So I think you have cleared this point. Second is sharp melting point. So sharp melting point, suppose you have taken some amount of a crystalline solid inside a tube and you are heating this content. So at a particular temperature, say 50 degrees Celsius, complete whole solids will be changed into liquid at 50 degrees Celsius, not at 49.9 degrees Celsius or not at 50.1 degrees Celsius. At sharp 50 degrees Celsius, whole solids will be changed into liquid. So this is known as sharp melting point. Mean at a particular temperature, whole solids will be converted into liquid. So what is melt over a range? You can write here gradual melting point. What will you write? Gradual melting point. So gradual melting point mean as you have taken some amount of solid in a test tube and you are heating at a particular temperature, say 50 degrees Celsius. Now at 50 degrees Celsius, it will start melting, but not completely. Some amount of this solid will be changed into the liquid. As the temperature will increase from 50 degrees Celsius to the 51 degrees Celsius, more amount of solid will be changed into the liquid. So suppose at 55 up to 55 degrees Celsius, this solid is changing into liquid. So 50 to 55 degrees Celsius, it is the range. Okay, it does not have a sharp at a particular temperature at which it converts into the liquid. It has a range that is from 50 degrees Celsius to 55 degrees Celsius. So it is considered as amorphous solid. Next, third point, important. This is regarded as true solid. So crystalline solids are true solid and these are regarded as pseudo solid. So what is this? Pseudo solids. So many times this term is asked in the question in the board exam. So you will keep in mind that what is pseudo solid. So pseudo solid represent the amorphous solid. So what does it indicate? It is also known as super cold liquid. The example is glass. Example is glass. So one question given in your board exam that glass is considered as pseudo solid. Why? So you will say it is not true solid, it is amorphous solid and it is super cold liquid. And how will you prove that it is super cold liquid? How will you prove that glass is a super cold liquid? So what will you say? When you will check the window pane of an ancient building, so you will get the higher thickness from the bottom. Okay, it's mean glass has a flow property, very low flow property. Okay, that's why the thickness at the bottom has increased as you will compare from the upside. So it's mean it has a flow property, mean it has liquid nature, and this liquid nature represent it as super cold liquid. Okay, now next difference is undergo regular cleavage. Undergo regular cleavage mean when you will cut the crystalline solid with a sharp edge of knife, then you will get a clean cleavage. I am giving one example, but this is not the crystalline solid. As you will cut the butter with a sharp edge of knife, then you will get 2 smooth pieces. So it represents the regular cleavage. So this type of solid is considered as crystalline solid. But again I am saying that butter is not the example of crystalline solid. I am just giving the example of clean cleavage. How will you get the clean cleavage? Okay. Now what is amorphous solid? If it will give the irregular cleavage. Example is when you will cut the coal from the knife, what will happen? It will give the irregular cut. Already you have checked at your home. When you will cut the coal, then you will get a irregular cut. So coal is the example of amorphous solid. Next is anisotropy. This is very important. This is very, very important. Board has asked so many times this question, what is anisotropy and isotropy? So anisotropy, aniso mean unequal, and tropy mean property. Okay, iso means same property. So what is this? This is very, very important. Students, listen carefully. I may ask this question in your unit test. Anisotropy and isotropy. So suppose this is a solid, for example, this is a solid. So who will tell the nature of the solid? You may write in the comment box. Okay. So when you will pass the current of this through this solid from point A to B, and you will check the value of current. Again, on passing the current from point A to C, you will check the value of current. If the value of current from point A to B and A to C is different, then the property electrical conductivity is considered as anisotropy. Here, electrical conductivity is known as, will be considered as anisotropy. So what is anisotropy? The property which will depend on the direction. How? The value of electrical conductivity from A to B is different than that of A to C. And similarly, it will be different from A to D. Okay. So this type of solid is known as crystalline solid, in which some properties like electrical conductivity, heat capacity, heat conductivity, all these properties depend on the direction. Then this solid is known as crystalline solid, and these properties will be considered as anisotropy in nature. So what is anisotropy? Which will depend on the direction. So this is the example of crystalline solid. So what will happen when you will move from point A to B? You are looking, there are two ions only. Okay, these two ions. And as you are moving from point A to B, there are four ions. And we know that electrical conductivity depends on the number of ions. Already you have studied in the physics. Electrical conductivity depends on the number of ions. So from point A to B there are four ions, and from A to B there are two ions. So definitely from point A to B the value of electrical conductivity will be higher than that of from point A to C. Okay, so it is anisotropy. So you will keep in mind that crystalline solid are anisotropy in nature, because on moving in different direction number of ions is different. So the value of heat conductivity, electrical conductivity, refractive index, heat capacity will be different in different direction. Now come to the amorphous solid. So I told you that amorphous solid has irregular pattern. Okay, so suppose this is amorphous solid. This is amorphous solid. It does not have proper orientation of the particle. Okay, so I am assigning again side A, B, C and D. Okay, so when you will move from point A to B, then you will get the same value of electrical conductivity in the direction of A to C. So as well as from A to D. Okay, this is D. So in all directions the value of heat capacity, electrical conductivity, refractive index, heat and heat conductivity, all these properties have same value in all direction, then this nature of solid is known as isotropy in nature, and such type of solids is considered as amorphous solid. So who will tell, by looking this diagram, who will tell why this type of solid has all similar properties in all direction? From A to B, how many ions are there? 3. And from point A to C, how many ions? Again 3. And point A to D, this and this, these 3 ions are in same alignment. So in all direction number of ions is same, that's why it has same properties in all direction. Okay students, so next point is definite geometry. Shape already we have studied in first point, that is regular internal arrangement of particle. Irregular shape already we have studied in first point. Don't have smooth cooling curve. Smooth cooling curve mean as you will decrease the temperature, then they will freeze like this. Okay, so there is no need to learn this point. Next is definite heat of fusion, mean when you will convert this solid into liquid, then definite heat of amount you will give to this solid. Okay, suppose you are giving 81 kilojoule per mole of heat to convert this solid into liquid, it will be same every time when you will take this solid. Okay, they don't have definite heat of fusion. Okay, so after completing the differences between crystalline and solid, next topic will be types of crystalline solid. So in types of crystalline solid there are 5 main types. First is ionic solid, second is metallic solid, third is molecular solid, fourth is network covalent, you can write here covalent solid, and fifth, no need to learn it, amorphous solid already we have studied. Okay, so there are 4 main types of crystalline solid. This is the further classification of crystalline solid. We will not discuss amorphous solid in this chapter. Okay, so ionic solid, metallic solid, molecular solid and network solid. Okay, this is the classification based on the types of particles which are forming the solid. Okay, structural unit. Structural unit mean what will be the constituent particle, ion, atom, molecule. So according to the type of constituent particles, crystalline solids are classified into 4 categories. First is ionic, second is metallic, third is molecular, and fourth is network. So we will discuss one by one. This is very important. You may get one question. Examiner will may ask a question in which he will give the one example from of ionic solid, one of metallic, one of molecular, and one of network solid. And he will mix all these solids together and will ask to separate these according to their types. Okay. So which one is metallic, which one is covalent, which one is ionic? It may be the question. Okay. So ionic solid constituent particles will be ions. Okay. For example, NaCl. NaCl. What is in NaCl? Na positive and Cl negative. So ions are there. So it is considered as ionic solid. Okay. Second thing, ions are held to, already you know that ions are held together by electrostatic force of attraction, or you can say ionic forces. So because of these ionic forces, they have very high melting point. Okay. And these are very hard. Already you have studied in the previous class. Now metallic solid constituent particles will be metal atom. Okay. For example, iron, silver, copper, all these are metal. And one trick is that example will be of periodic table. Okay. Periodic table. Element will be from the periodic table. So if any example which is the example of periodic table, then you will classify that element into the metallic solid. Okay. So electrostatic attraction, you can write here metallic bond. Metallic bond. Electrostatic, in place of electrostatic attraction, you can write metallic bond or metallic forces. These are very, very weak forces, not strong forces. Okay. And because of this, these are malleable, because these are very weak forces. So these are malleable. Malleable mean you can convert whole solid into a wire. Okay. Ductile, you can convert the solid into a sheet. And you know that metal conducts electricity in solid state because they have free electrons. So this may be the question. Students, listen, very, very important question. Last time this question, I assigned this question in the unit test. Okay. In the previous, you can ask from those from the students who have completed the class 12. So what is ionic solid and metallic solid? So question was that what is the characteristic distinguish between ionic solid and metallic solid? I am asking the characteristic. You will not say constant particles are ions, constant particles are metal. This is not characteristic. How will you come to know that the given solid is ionic solid and metallic solid? Suppose I am giving a NaCl powder. NaCl powder is white color crystalline solid, already you know that. Okay. And I am giving silver. Okay. Silver. I made a powdered form of silver and asking how will you come to know which is NaCl and which is silver? Both will look like a white crystalline solid. So how will you come to know which is NaCl and which is silver? So you will go for the characteristic solid. Okay. In 10th class, you have studied that ionic solid in solid state does not conduct the electricity because ions are held together by a strong attractive force, and this attractive force does not allow the ions to move from one place to another place, or you can say from cathode to anode. That's why ionic solid does not conduct the electricity. But in metallic solid, you know that metals conduct the electricity. Metal wire, aluminum wire conduct the electricity. Iron rod conduct the electricity. That this is the characteristic feature. So the two test tube, which is filled by, one is filled by NaCl and another is filled by powdered Ag. So what will you do? You will try to conduct the current from the NaCl. So NaCl will not conduct, but when you will try to conduct the electric current through the powdered silver, then electricity will be conducted. So it will be the metallic solid and it will be the crystalline ionic solid. Okay. Next is third is molecular solid. So before this we will discuss the network solid. So network solid, atoms with infinite 2 or 3D network. So already as you studied the nature of diamond. So what is the nature of diamond? Carbon has 4 bond, mean it is tetravalent. So on each valency again carbon is there, and now these carbon will again form 4 bond with another carbon. So it will be the infinite pattern. Okay. So what will happen in this pattern? In 11th class we have studied that the bond between the similar atom is very, very strong. Okay. So bond between carbon is very strong. This bond mean all bonds are very strong. That's why this pattern, that is, this is known as network covalent bond. This network covalent bond gives the some special properties, like it is very, very hard, it has very, very high melting point, very, very high boiling point. So even if from the if you will compare network solid with the ionic solid, then you will come to know that network covalent solid has very high melting point than the ionic solid. So why this is very, very these solids have very high melting point? Because of network solid. Okay. And another example of network solid, first is diamond. Okay. Second is graphite. So what is the difference between diamond and graphite? In graphite, each carbon form only 3 bonds. Okay, each carbon form only 3 bonds, and these bonds are formed in a ring pattern. Okay, like ring mean closed cyclic system. Okay, each carbon will form 3 bonds, and we have studied in class 11 that carbon forms 4 bonds, but here are 3 bonds. It means each carbon has 1 free electron. which is not used by the carbon in the bond formation. If each carbon will have a free electron, so it means this structure may conduct the electricity because of free electron. This is the distinguish between diamond and graphite. Diamond does not conduct electricity because all valence electrons has been used in the bond formation, but in graphite one electron on each carbon is left, so this free electron will be responsible for the conduction of electricity. Okay, next another example is that what is quartz? Quartz is a crystalline form of sand. What is the formula of sand? SiO2. So we keep in mind that sand is a amorphous form and quartz is a crystalline form. So what examiner may ask the question, what type of solid you will classify in which category? So SiO2 will be the network solid. SiO2 will be the network solid. Okay. Another example is aluminum nitride, ALN. Okay, aluminum nitride. Silicon carbide. Silicon carbide. You will tell its name already. I have told you in class 11, chapter P block element, group 14. Okay, common name is there, and I am giving hint. It is started with the alphabet C. So we'll write in the comment box what is the name of SiC, silicon carbide. Except silicon carbide, one more name is there. So we'll write in the comment box. Okay, so aluminum nitride, silicon carbide, SiO2, diamond, graphite, all these are the example of network solid. And what is the characteristic of network solid? They have very high melting point, even very high than the ionic solid. Okay, next is molecular solid. Next and last is molecular solid. So in molecular solid, constituent particles will be the molecule, and the type of attraction will be very weak attractive forces, and these very weak forces already we have studied in the chapter states of matter. First topic was types of attractive forces, in which I told you about the van der Waals forces, dispersion forces, dipole interaction, hydrogen bonded. So example is H2, O2, CH4. Here molecular solid are further classified into three categories. First is polar, second is non-polar, and third is hydrogen bonded. So polar, for example, HCl. HCl is polar or not? Because chlorine has higher electronegativity than that of H. So it will be considered, this is delta. So it will be considered as a polar covalent solid. Non-polar, H2. So out of these two, hydrogen which will withdraw the electron towards itself? No one, because both have same electronegativity. So this H2 is considered as the non-polar molecular solid. And hydrogen bonded, you know that water will form the hydrogen bond with another molecule or not? Because I told you that hydrogen will form the hydrogen bond with phone, mean fluorine, oxygen and nitrogen. This is the topic of 11th class. Okay, so I will not give more time on this topic. So molecular solid are further classified into the polar, non-polar and hydrogen bonded. So you will tell me about these three examples. Hydrogen will be considered as polar, non-polar, and oxygen again non-polar, methane non-polar. So you may write water, it is the example of hydrogen bonded, HCl, it is the example of polar crystalline molecular solid. So next topic, we will discuss some questions. For example, classify the following as amorphous and crystalline solid. Okay, so students, already I have told you that benzoic acid, potassium nitrate, copper, all these are crystalline solid. How? A trick is there. If poly word is there, then this solid will be considered as amorphous solid. Okay, you will keep in mind that polymers are amorphous solid. So polyethene is polymer, naphthalene is polymer, in which two benzene are there. So it will be considered as the polymer. Polymer means in which same unit is repeated number of times. Okay, so polyethene, naphthalene, Teflon is the polymer of CF2 double bond CF2. Already you will study in the chapter polymer. Okay, cellophane is also polymer. Polyvinyl chloride is polymer. Fibers are polymer. Glass already we have studied, it is amorphous solid, and all these are what? Amorphous solid. And in crystalline solid, next crystalline solid. So you will tell me the nature. Benzoic acid. Okay. Then potassium nitrate, KNO3. It will be ionic or not? Ionic solid. Copper, metallic solid. Okay. Next, you will look for the question number 16. So question number 16, classify the following solid into different categories based on the nature of intermolecular forces. Potassium sulfate, ionic solid. Tin, ये element है. So it will be the metallic solid. Benzene, non-polar molecular solid. Urea, NH2CO NH2. Okay, so this is the formula. So NH2CO mean it is polar. C positive, O is negative, polar molecular solid. Ammonia, hydrogen bonded, like water. Water again hydrogen bonded. Next is zinc sulfate. Already zinc is 2 positive and sulfate is 2 negative, mean ionic solid. Next is graphite is crystalline network solid. Even just now I told you that it has ring type structure, one free electron on each carbon. That's why it is responsible for the electrical conductivity. Rubidium, it is element. Okay, so again metallic solid. Organ, noble gases are considered as molecular solid, not metallic solid. Okay, so because these are considered as monoatomic gases ना. Okay, silicon carbide SiC again, जिसका मैंने नाम भी पूछा है, silicon carbide aluminum nitride. So these all are the example of network solid: aluminum nitride, silicon carbide, and graphite. Okay, next two questions, then we will stop this video. A solid A is very hard electrical insulator of in a solid as well as in molten state, and melt extremely at high temperature. What type of solid is it? So a very hard electrical insulator है, like diamond, and molten state maybe क्या है ये electrical insulator है, melt extremely high temperature. So what type? So you will write network solid. So you can write a diamond as well as sand, SiO2 parts. Both diamond and quartz do not contain the electricity in solid or in molten state. But 68 question is that which network solid is exceptionally good conductor of electricity? So graphite. Okay, so hope you will like this video. If you have any doubt, then you can write in the comment box. I will try to clear it in the next video. Thank you, students.